This black and white image might look boring, but it represents a paradigm shift in our understanding of the size of our cosmos. You see, at the beginning of the 20th century, we were not sure if our universe was limited to our galaxy, the Milky Way, or if it was bigger than that. Astronomers were not sure if the spiral nebula that they were observing were a part of the Milky Way or distant galaxies similar to our own. On the 26th of April 1920, exactly 100 years ago, at the Smithsonian Museum of Natural History, a debate raged among two leading astronomers, Harlow Shapley and Herbert Curtis, in what came to be known as astronomy's Great Debate, also known as the Shapley-Curtis debate. Shapley believed that the distant nebula were relatively small and lay in the outskirts of our home galaxy, the Milky Way, while Curtis held that they were in fact independent galaxies, implying that they were exceedingly large and distant. Each argument was detailed, but no consensus was reached as they couldn't tell how far these spiral nebula were from the Earth. The answer to this came over 3 years later, in the form of this seemingly boring photographic plate. To measure the distance to a distant astronomical object, we need to know its intrinsic or actual brightness and its apparent brightness, that is how bright it appears to be. And with the help of the inverse squared law, we can measure its distance. Thanks to Henrietta Leavitt and her pioneering work, which had led to the discovery of Cepheid variables, we had a formula that related intrinsic brightness and period of these stars that varied in their brightness at regular intervals of time. A tiny little star on the top right of the Andromeda Nebula seemed to be changing in brightness when compared to an earlier observation, and Hubble marked it as N for no way. But on subsequent observations, he saw that the star got brighter and dimmer at regular intervals of time, which got him excited. This can be seen in him striking off N and writing var for variable with an exclamation. A variable star meant that they could calculate its intrinsic brightness, and keying this into the inverse square law would give them the distance to this nebula. 2.5 million light years away. This is how far the star and the nebula that housed the star was from us. Our galaxy was just 100,000 light years across. This meant that it had to be a nebula outside of our galaxy. With this one image, our understanding of the size of our universe exploded. Thanks to the Hubble Space Telescope, in recent years, our understanding of the universe we live in has just gotten deeper. Deep exposures of tiny patches of the sky where nothing has been observed before have revealed hundreds and thousands of distant galaxies. We now know that our galaxy is just one among the 100 billion other galaxies that are in this universe.